In this video, I'll talk about how to interpret hypothesis tests. You start out with writing a formal hypothesis, and once you have that, you calculate your p-value. If you have a small p-value, this provides evidence that H0 is probably not true. So it provides evidence against H0, the null hypothesis, that is. That is, it's really unlikely for this to happen with H0. So an example, say your p-value is equal to 0.02. So in this case, we say it's statistically significant at the 2% level. Often in practice, you'll see numbers like p equals something like 6.42, blah, 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 a whole bunch of numbers. And then you'll see this like e -5. So when you see a number like this on the computer, this is what the computer shows. Don't pay any attention to the first part here. That doesn't matter. This e -5, this is what matters. And this is telling you this number is like, it's on the order of 10 to the -5. So 0.00001. It's on that order of magnitude. So it's very small. In which case you have a lot of evidence against whatever your null hypothesis is. So the other thing that can happen beside a small p-value is if you get a large p-value. For example, p greater than 0.1. I've never heard of people doing hypothesis tests and not rejecting for anything greater than 0.1. So 0.1 is probably a good threshold for being too large. No one that I'm aware of does hypothesis tests like this. So in this case, you can't conclude anything really. H0, the null hypothesis, is plausible. And H1, the alternative hypothesis, is also plausible. You just don't know. So here's an example where you don't know with simulation. So I just performed this experiment. I take n equals 100 observations from a normal, instead of mean 0, I take mean 0.001 and variance equals 1. Okay? So I test the hypothesis H0 that mu is equal to 0. I know for a fact that H0 is false because mu is actually 0.001. So H0 is for sure wrong. But when I did this just one time, I end up, I get a z value of, so I compute the mean of these random numbers, and I convert that into a z value. My z value is negative 0.5366. I can now calculate the p-value under the null hypothesis, and the p-value equals 0.59 approximately. So in this case, the null hypothesis was false but we got a large p-value. So having a large p-value does not show that the null hypothesis is true.